with a breakthrough in stem cell research that could solve both medical and ethical dilemmas, and it's happening right here in Singapore. CellResearch Corporation has recently found that the outer lining of the umbilical cord is a rich source of stem cells which can be converted into a variety of healthy cells. Diseases such as cancer, Alzheimer's, and diabetes could benefit from this new discovery. For more on this breakthrough, I'm now joined by Dr. Ivor Lim, Medical Director at CellResearch, and Dr. Phan Tuan Tang, Chief Scientist. Welcome to you both.
Thank you very much.
And a very exciting discovery here. So it really could change sort of the whole medical kind of research when it comes to stem cell. Dr. Lim, let me begin with you.
Sure.
I mean, how huge is this discovery?
I think what is important for this discovery is that it covers so much ground. First of all, the yield of stem cells is extremely high from the umbilical cord. It has two types of stem cells, both the epithelial and mesenchymal cell types. And furthermore, it comes from a source which is routinely discarded as afterbirth on the delivery of a child. So I think it's very exciting indeed, because in addition to which we've found the cells even express some evidence, some characteristics which might indicate embryonic stem cell characteristics. So it's very exciting. It
is very exciting because, of course, as I mentioned, the ethical issue is one that has been very controversial when it comes to stem cells, because usually it's a case of trying to get stem cells from an embryo, and that's where a lot of people have problems with this. But so this is important because it avoids that whole ethical dilemma, doesn't it, Phan?
Sure, yeah. And actually, when we start with the placenta amniotic stem cells, but we found actually umbilical lining is quite easy to process and easy to handle, compared to placenta and other sources as well. And we also found actually, because cord blood is quite long, about 30 to 50 cm length, with a 1 to 2 cm diameter, so we can have a huge tissue.
Wow, just from one umbilical cord.
Yeah.
So you're able to process much more from that particular cord. So is it, though, as effective as the stem cells we hear so much about from the embryo?
It's too early for us to because we need a lot of experiment to verify, so it's a lot of work for us to do, but this one is quite new source of cells, so we need to work more on this to verify, see how good and how close they are compared to embryonic stem cell and how effective they are compared to embryonic stem cell.
So what potential are we talking about here, Dr. Lim?
Well, at the current time, we've managed to differentiate the cells into skin cells, fat cells, as well as bone cells. So if you can imagine, if we can then differentiate the constituent cells, we could potentially be able to engineer an entire organ with or without a synthetic scaffold. So in terms of straightforward applications at the current time, we can use the cells we've just described, skin, bone, or fat. But downstream, we're thinking in terms of something more adventurous, something more sophisticated,
such
where
as?
you can actually make an organ. I mean, of course, that will be in the future. But I think as long as we have the technology and the basic stuff to work with, which are these stem cells, it might well be a distinct possibility.
So for the average person out there who's listening to what you're saying, very scientific, it's very medical, but just from a layman's point of view, when you were talking about diseases like cancer and Alzheimer's and diabetes, this kind of research could really change sort of the face of treating these types of diseases, couldn't it?
Because at the current time, our emphasis as doctors in treatment is the treatment of the disease process itself. So we're hoping that with this new technology, we're able to actually utilize good cells to replace cells which have gone awry or have been lost from trauma, to restore that function. So it's a restoration and repair from the very, very basic building blocks.
And Dr. Phan, I'm curious, Singapore is trying to become sort of the biotech research hub in the world, and especially with stem cell research, it's really invested a lot in that type of research. So how advanced is it truly in Singapore compared to other research centers around the world?
I think we are not behind any sentence. Once we are actually, we are quite advanced, and our government put a lot of effort, and we have a lot of good scientists here around the world. And I've been in US and UK before, and then actually I think it's a good opportunity for me to do work in Singapore. So I decided to go back to Asia and in Singapore to base here.
Right, right. And it seems like a lot of experts are coming to Singapore, flocking to Singapore because of this. And so do you think this could possibly put Singapore on the map when it comes to stem cell research?
Well, Singapore is already on the map for embryonic stem cell research. We hope that with this new discovery, perhaps it could increase the international understanding of what is available in Singapore for research and further development.
Yeah, but very exciting stuff.
Thank you very much.
So congratulations to you both. Good work, and I wish you well.
Thank you.
All right, thank you very much.
Thank you.